All right, so talk today is going to be about React.js, functional UI in a dysfunctional world. That's the name of the presentation. I'll get into what React is, how functional concepts in front-end development can help us architect our applications in a more elegant way. It can help us manage state in a more maintainable way. So I'll get into all that. But first I just want to introduce myself. My name is Chris. A lot of people, Chris Cordell. A lot of people call me Crisco. I do accept donations. That's a real thing. These are some of the skills that I have. I started Ultimate as an intern about 3 years ago. When I started, I was very involved on the Meta platform, and I used Knockout that summer and learned Knockout, and it really opened my mind to the idea that when you use certain libraries and tools, it can reduce the amount of code that your program has. I used jQuery prior to that summer, and then when I learned Knockout, I was able to reduce an old application I had done from 1,000 lines of code of jQuery to only 200 lines of code with Knockout. So I do get that certain tools and certain architectures do really improve your productivity as a developer. And the case I want to make today is that React is an evolution beyond Knockout and perhaps even Angular that can improve your code. Maybe not necessarily lines of code, but it will make your code easier to reason about, easier to test, and easier to maintain and grow as your application grows. So a lot of these JavaScript frameworks are trying to give you a model for the MVC paradigm. This architecture was invented back in the 70s. It's been around a long time. We all think that we know what this means if we've used an MVC framework of any kind. We have our model, which updates our view. Our view is shown to the user interacts with the controller, which then manipulates the model. This model seems very simple to us conceptually, but the thing is, the more you explore out there, the more you realize that there's a lot of different definitions for MVC. Here's another diagram with the controller in the middle, and the model notifying the controller updating the view. Just one slide back, we had the model updating the view. So here's a third diagram. I mean, depending on which source you're using to learn MVC, you may have slightly different arrows in mind whenever you think of your application's structure. And all this is attempting to make your code easier to reason about, to separate the concerns in your application. But as you find that when you're using all these different frameworks, they all have different ways of implementing this. And that's why all these diagrams look different. In fact, Knockout, for example, is an MVVM framework. It has model view model as a concept, and now it introduces a view model instead of a controller. So what does this mean at an abstract level? It's really hard to get a clear definition for what all these terms mean, and how to. It's really hard from these diagrams to understand how to architect your front end in a consistent manner. So React has been described as the V in MVC, just the V, so just the view. You might ask, why would I want just the V when I already have an MVC framework? I already have Angular, I already have Knockout. Why would I want to limit myself to just the V? In other words, if you had this as a puzzle, why would you buy a V, right? So, all right, as I've said before, there's a lot of different MVC frameworks out there. Here's a few of them. These are some of the most popular ones. Before I get into that, I want to explain the difference between a library and a framework. Okay, so a library is a it's simply it defines points, and your program calls functions and maybe some objects and properties that are defined on that library. But a framework gives you a lot of extensible points that your application interacts with. So your code lives inside the framework versus using a library that you can just plug and change out at will, assuming you can find a library that provides the same functionality. So what's in practice, what are these various JavaScript frameworks that we've used in the past? How do they fit into this breakdown? Well, jQuery is a common library that we use. Knockout as well. Underscore, React. They're all considered libraries, whereas Angular, Ember, Aurelia, etc. are all frameworks. And there's some pros and cons to using libraries versus frameworks. So one of the benefits of using frameworks, you get a lot out of the box. You may get routing, you may get authentication, you may get user management, AJAX handling, you may even get some test abstractions that help you with testing your code. So there's a lot of benefits. You get a lot, there's batteries included with a lot of the frameworks that are there. But there's some pitfalls. There's some disadvantages of using frameworks. You're going all in when you implement a framework. It's very hard to swap out. It's very hard to swap out a framework. It's very hard to go Angular and then decide that you want to go Ember, for example. You're not able to compose them. You can't compose some of the ideas from Ember with some of the ideas from Angular. It's difficult to mix those concepts. The second bullet point said that it violates the do one thing well Unix philosophy. For those of y'all familiar with the Unix philosophy, it's just the idea of breaking things into simple programs that you can string a lot of simple programs together using the piping mechanism in the Unix terminal, for example, and you can achieve complex behavior by composing the outputs of all those programs. Another problem is a master dependency graph within your application. You're depending on that framework to handle a lot of magic in the background, and you may not know or understand exactly how that works at first because you're just building your business logic until you hit a problem, and then you have to go in and read the source code for the framework to understand why this thing that you're trying to do isn't working. So I've used Angular in the past. I'm of all those frameworks that I showed before, Angular is the one I'm most familiar with. I'm currently using it on a project. But this is the experience a lot of people have with Angular over time. As they've initially hit a high point where they're able to get a cool application with only a few lines of code, and then they wonder what's the difference between a service and a factory. What's the difference there? Why are there two different things like that? And how does that relate to my understanding of what a service is? So you figure that out, you read more source code, you figure it out, and then you run into directives, and you're like, okay, directives are cool, I can create custom HTML components, that's great. But then you start to wonder, okay, what's transclusion? What's the difference if I use bind to controller or controller as? Like, why are the examples different than what the best practices are suggested that I do? There's a lot of like ups and downs in your development as an Angular programmer. And maybe at the end of the day, you might think that it's the most awesome framework ever. But that doesn't mean necessarily that framework, suppose you did come to the conclusion that Angular was the most awesome framework ever. You may be convinced of that based off of the reading of the community. You may find that something that's more popular, you may begin to convince yourself that it's superior to everything that's out there. So I would posit that just because it's popular doesn't mean that it's a superior way to build applications. So just keep that in mind. I do think that maybe it is the best framework ever, but maybe it's better to use a library and to architect your application on your own. Okay, so let me get into React.js. and what it is. It is three simple ideas. It is functional UI components, virtual DOM, and one-way data flow. And I'll get into why those are powerful concepts and what that enables you to do. Okay, so first let's explain what functional is. When we're talking functional in a mathematical sense. Functional programming, for those of you, I mean, in computer science, we tend to be taught object-oriented programming and imperative-style programming, but functional programming is making a comeback, and it's finding a lot of traction in the field with languages like Elm and Clojure. So it's important that we learn this, and I think that a lot of the concepts around React have come from the functional programming spectrum. But essentially, we want to think of, we want to avoid, like if you look at this definition, it says treats computation as the evaluation of mathematical functions and avoids changing state and mutable data. Why do we want to avoid changing state within a function? Well, because state is complex. It's complex. It's hard for us as humans to keep a lot of state in our heads at the same time. So when you create a function that is not concerned with the state outside of its world, then you can make a function that's easier to reason about, easier to test, and you can just focus on what that function is supposed to output given a set of inputs. So that's just like when we learned from Algebra 1, f of x yields x. That's one of the simplest functions you can think of, and that's what we're getting at with React.js and its functional UI components. Instead of inputting variables, we are inputting variables. We're inputting state and properties that we pass in as tags on these custom HTML components, and we're outputting HTML. That's the output of the function. So that is essentially what a React component is at a high level. It's just taking in some parameters, outputting some HTML snippets. It will always produce exactly one snippet. Given a set of inputs, it will always produce exactly one snippet. It will not change state outside of its concern. A React component will only deal with the state inside of its box, per se. It won't worry about the state of your application. It won't mutate some other component somewhere else. It won't call a parent $parent or something like that and modify a state variable at an upper level. That's something that I think is an anti-pattern in UI development, but it's common sometimes in Angular and knockout development. Okay, so important point is that React components simply describe what should be output to the UI layer, nothing more, nothing less. That's just what we're getting at. So let me do like a quick example just to show you how this works in practice. So I'm going to jump over to some code. Okay. All right. So this is probably really tiny. I'm going to try to zoom in here. Okay, don't worry about that. I am making use of some tools for this, including Webpack. Webpack is a great tool for web development, even if you're not using React. It's great for compiling or transpiling less CSS. If you're using TypeScript, it's great for compiling things or transpiling things into different formats. So I am using this as a compiler as a tool to compile my React components. I'm also going to be using ECMAScript 6 for those of you, for all these examples. For those of you unfamiliar, that's the latest version of JavaScript. It's also called ECMAScript 2015. These are tools where if you use something like Webpack, you can transpile ES6 into legacy browser compatible ES5 JavaScript code. That means that you can use transpilers to use the latest standards today for application development. If you want to learn more about Webpack, I do have a article in Confluence if you look up the Ulti research page. We do have a Confluence article on how to set up Webpack on there. Okay, so let me begin by starting with the entry point. Okay, so I'm using. Oh, can you guys on WebEx mute your mic, please? All right. So let me zoom in here so we can see better. Okay, right here you see a couple of import statements that may look unfamiliar for people who haven't learned the new ES6 module syntax. But essentially I'm just importing a JavaScript file as a dependency on this file. So it's just like you can think of it as a C# include or any other programming language you use. So JavaScript's grown up, now it has its own module syntax, and you don't necessarily have to use require or CommonJS style. This is the new ES6 standard. So I'm importing right here, this hello box. I'm importing a component, and that's a React component. I'm also importing React because that's a dependency for this render method. Okay, so I'm calling React, I'm calling the render method on React. I'm passing in the hello box component. I'm simply right here, the second argument is telling it where to mount that component. So I'm just getting the body tag of the HTML, and then I'm just inserting that component as a child. This hello box component is a child of the body element. So at its core, that's what React does. It just simply renders UI. So what is the hello box component? How have I defined that? Well, I can just command click into it. And I'll show you that this is a React class. So this is a React component class. I'm extending React component, and then I'm defining a constructor, calling the super method on it, and then defining a render method. So all React components have a render method that simply defines the HTML that you want to render whenever your component is put on whenever your component is called. Okay, so this syntax might look weird to you, this div right here. What is this HTML doing in my JavaScript? Well, this is actually not HTML per se, and I'll get into more on that a little later, but what this is JSX, which means JavaScript XML. It's HTML-like. It's very similar to HTML. It's meant to look like HTML so that it's easy to just put it right in your component. Now at first, I saw this and I kind of thought it was ugly, like mixing HTML with my JavaScript. It sounded like a smell to me. But the more I've learned about like React components and how they work, because everything is the way React is structured, it forces you to break things up into components in order to describe your application. And it's better to have your HTML and your logic for a component all in one file. You could separate them into separate files. In fact, I could do that here. But I think it's better when your component is simple enough, and the component should be, to just have them in the single file. You don't have to switch back and forth between files to look at your HTML and your JavaScript and see like what you need to change. So let me go into this a little more. Let me explain this a little better. We're rendering a div, which is just an HTML div, and then we're rendering a hello text component. And we're passing in a string, the string ultimate, into that component. Now I could pass in JavaScript, but for this example, I just hard-coded a string that I'm passing in as a prop called name on the hello text component. Okay, so let's click into the hello text component to see how that looks. Okay, so the hello text component is a p tag. It's just a HTML p tag, and it's got hello with the mustache style brackets. That's including this.props.name. That responds that is just simply rendering the text from the props right inside the p tag. So it's just this.props is something that a React component has access to. That's going back to that function diagram where I said a React component is a function of state and props. And these are the props that you can pass in from the parent components to the child components so that they can render this to the screen. Okay, so what does this look when we render this? We just run and it's working. So let's go to Chrome and let me browse to the screen. Okay, so we've got just Hello Ultimate. That's the simple Hello World example. Just as an aside, I want to show you kind of the power of I guess the ability to just include things as module dependencies. So say I wanted to add some styling to that component. I've added this class big text, and you will notice that it does say class name, not class. That's because class is a protected word in JavaScript, and to reconcile the fact that I'm writing JavaScript or I'm writing XML inside JavaScript, they had to change class to class name so that you could add classes to your tags without interfering with like this class, for example, and it wouldn't the compiler wouldn't mistake that as a JavaScript class. So one cool thing that I can do is I can include some CSS or some I can include some CSS or some Sass right here. Okay, so I can include some Sass into my application, just import it as a dependency, and then whenever I refresh this, the Sass has loaded to change the style. So I mean that's pretty neat. I can just include CSS as a dependency and manage my component my component styles that way. Okay, so let me get on with the presentation. Here. Alright, so virtual DOM. What is virtual DOM and why does it matter? Okay, so when your UI is described as a composition of functions, then each time state changes, the entire application's UI has to be recalculated and re-rendered to the screen. That's could be seen as a disadvantage of the functional paradigm versus just mutating a quick state variable somewhere. Of course, with Angular and Knockout, you have things like dirty checking and you have the whole digest loop. So there's some disadvantages with that paradigm as well. But let me explain why this might be a computationally expensive process. Okay, say we've got, at the high level, we've got state and props that are getting passed in to a root node. Let's say it's a div in this case. And then that div has child elements, and like let's say the second child is a form element, and then that form element has an input element on it. So if the state and the properties change, like say a user types into the input and then an event is fired that changes the state, well, that state is going to get propagated back to the root node of your application, and then the props are going to be passed back down through to the child components, and each of these orange circles represents like a re-rendering of that element. So because the input to each component has changed, the output has changed. So we've had to re-render everything in our application. So that's an expensive process. So so the solution to this problem is virtual DOM. So instead of this is Facebook's solution to this problem. Instead of re-rendering the entire application, we're just going to diff what's changed. We're going to change a virtual DOM in memory in JavaScript, and we're going to then diff that with what is currently on the screen. This is similar to Git's diff algorithm for figuring out what's changed between two commits. So we've got a mock DOM in memory, and in this case we're only going to re-render the input element. So what is it in practice? The virtual DOM is a stripped down JavaScript edition of the HTML DOM. You just saw some of that with the XML inside the JavaScript. It's faster for us to do re-rendering if we have a virtual DOM, because we can compute in memory without worrying about the rendering step, without worrying about reapplying CSS rules. We can compute what the state of the application should be as a function of props and state. We can determine what the UI should look like without worrying about the very expensive rendering process and the browser level. This actually opens up a lot of interesting possibilities that wouldn't be possible without the virtual DOM abstraction. So virtual DOM was meant to solve the performance problem, but it kind of created some other additional side benefits as well. By abstracting the DOM into JavaScript directly, instead of by abstracting it, it means that React is platform independent. The DOM is, the virtual DOM can represent, if you create the diffing for like a virtual DOM with, say, iOS components, then you can build native applications with this React architecture, with this React library. So that's what Facebook has done. They've created and released React Native, where you can build native applications using JavaScript and virtual DOM, and the virtual DOM simply diffs with the iOS components to determine the state of the UI. The second point here is that it means that on a node server, if you're running on a node server, you've got JavaScript runtime on your server. That means you can do server-side rendering. What is server-side rendering? Server-side rendering is where, when the initial page is loaded, all the client-side logic is computed to determine the HTML output before it gets sent down to the user. So when the user loads your initial page, it can figure out where all the data binding is supposed to go, where it can figure all that out and just send it as pure HTML to the client on the first page load. That means that even robots can see the result of your application without having to worry about AJAX calls or anything else, without even having to worry about the like on Knockout, for example. Yes, you can from the server pass in properties to your HTML, but then you have to use Knockout to apply the bindings to the HTML. So you have to wait for Knockout to load, wait for everything to load before you can render that HTML to the client. This enables you to send pure HTML to the client. It loads super fast. It will load even before the React library loads, and it will look right. So that's a super good benefit for making mobile friendly and SE search engine friendly websites. Okay, so I'll go into explaining JSX. Okay, so what you see here is you've got a render function on a React component, and then you've got this return statement, which is returning. Right here we see pure JavaScript. This is the JavaScript we're familiar with. React.createElement, which is a function, and then we're passing in parameters to that createElement function. Okay, so you can use React in this way. You can just write pure JavaScript without using JSX. That's a choice that you get to make as a developer. They don't force JSX down your throat if you don't like the idea of having HTML in your JavaScript. I think you'll find that if you, in practice, while at first it might feel uncomfortable, it's actually a big performance gain from a productivity standpoint. So that's what JSX is at the end of the day. It is JavaScript. So this, I mean, that might look bad, but this might, I think this looks better. I think this looks better. This dot state dot seconds elapsed. I think that's easier to reason about than this create element div, and then you look in and pass the parameters to that. You know, this gets compiled through a JSX compiler or transpiler into this. So when you look at your source code, you're going to see this. Okay. So you might think, like, what about separation of concerns? What about, like, this is how we generally think how we should do web applications. We have our HTML, which represents our content, and our structure, and then we have CSS, which represents the presentation layer. That's how everything should be styled. And then the JS is the logic on the client side. So that might be good advice. You know, it's been pretty cramped down our throats that should be how we separate our concerns to when we build web applications. But as Will Rogers says, it's not what we know that hurts, it's what we know that ain't so. So whenever things change in development paradigms, maybe we need to rethink what our best practices are in our minds. Maybe we need to make sure our assumptions are still true. We need to look at when you're building an application where everything in your application is a component and a functional component. I think that it's arguably better to keep the logic, the content, and maybe even the presentation, like the CSS, inside the component in one file. It doesn't mean the concerns aren't separate. It doesn't mean you're mixing business logic with presentation logic. Render, for example, should not contain business logic. It should just contain UI logic. As I said before, there's no need to tap back and forth, and JSX syntax highlighting is available in code editor, so it's easy to look at even. Okay, what's the final piece of the puzzle with React is one-way data flow. So the benefit of having functional components that describe how your application should look given a set of state and props is that you get a one-way data flow from the root to the child to the leaf nodes of your DOM. So this is how that looks in practice. You have a render method that's passed to a parent. That parent, maybe an event gets set off, maybe somebody clicks something, maybe some AJAX is received, a state variable is set, and then the render is reapplied, and then the render for the children are reapplied if that's necessary. The child is ignorant of the parent. The parent is ignorant of the root. That's key to reducing the complexity of your front-end code. This way your components are testable in isolation. It really helps out a lot with code. I'll show a more complex example in just a little bit. Okay, so you might be thinking, okay, great, React is great, but what about the M and the C? What do I do? I'm missing some letters here. How do I deal with that? So it's pretty simple. Like, model is your state, and that's a decision that you get to make now as a developer, because you're not using a framework, you're using a library. So what do you use to represent your state? Well, probably the most obvious one would be just plain old boring JavaScript objects. There's no need to use some weird factory or service paradigm in order to represent your state. There's no need to worry about controller as syntax or transclusion or anything like that. There's no need to worry about deciding whether to use two-way data binding or one-way data binding or some mix of the two. You just use plain objects, and you just pass in subsets of that object into your components. This does show, like, I have plain old objects, or I have immutable objects. Immutable is another library that you can use, which allows you to create objects that cannot change. In other words, it just protects the objects from changing state. Whenever you change state in an immutable object, it produces a new object. It doesn't mutate that object directly. It creates a new object in memory, and then we swap out the new object for the old object. Okay, so how about the C? What about the controller? What about the logic and behavior of our application? Where do we put all that? Well, we simply define functions. We just use functions. That's it. It's really that simple. Now, again, with the freedom that using libraries enables you to do, there's a lot of responsibility. You've got more responsibility over how you handle routing, how you handle, maybe you need to import or include a routing library. Maybe you need to import or include a testing framework. Maybe you need to import or include your own, and you can create your own, or you can use some open source library to achieve all those components. And you get a problem where you kind of have to create a mix and match. I would say that is a good thing, because you're going to be more familiar with how your application is architected. There's going to be no magic, and you're not going to have to read Angular source code in order to understand why your application won't do what it's doing. So that's the thing. So, okay, Chris, you say that's great, but I still don't know where to start with structuring my application. Okay, well, Facebook came out with a spec that describes how you might architect a front-end application when you're using something like React. And this is just a suggestion. Flux is what the name of it's called. It's just a suggestion. It's just a set of ideas. It's not a framework that you can download. You can't download Flux. You can't npm include, or you can't just download Flux straight up. There's a lot of implementations out in the wild, but it's just an architectural outline, just an idea. It's almost like the model view controller idea. There's a lot of implementations out there, and depending on which one you use, the arrows are going to look different. So here's the diagram of how the Flux architecture is. A Flux architecture, a Flux application introduces a couple of new concepts. So we see our view right here. This is what React is concerned with, is the V in the MVC, right? But try not to think in terms of pure MVC, model updates view, view updates controller. Try not to think in terms of that, because Flux is slightly different. In practice, it is at some level an MVC framework or of MVC architecture. But this right here is your React components. The React components, they don't directly mutate state, even their own state. They just emit actions. And actions you can think of are events. They are events that contain the relevant state from that action, from that event. And I'll show what this is in detail in another slide. And those actions get dispatched to a dispatcher, and then the dispatcher sends that to the store, which is where your state is stored. Okay, so this is, again, a one-way data flow. So we're going back to the dispatcher, we're updating the stores, and then the stores are changing state variables, which are then updating the view. All right, actions. Let me show you what a couple of actions might look like. Okay, they describe what occurred. So instead of the components, like in an imperative style programming, you might have, whenever somebody clicks the button, you might change a state variable in your application in order to let the rest of the application know. But Flux says you shouldn't change state directly from a component. You should simply emit an event. Emit an event. Just publish an event out there. Let the dispatcher send it to who cares about that event. And these are two actions that you might create. Create message is the type. That's just a string constant. And then the payload, which is, in the first one, might be the text that somebody created for the message. Or clicking a thread, for example, might be a thread ID. So the relevant data for that action is included with the action as a payload. It's then sent to the dispatcher. Where are we at? Okay, it's then sent to the dispatcher. I'm no longer connected. I lost my max. Sorry, guys. Is there something I can hit here to help it automatically reconnect? Does anyone know WebEx right now?
I'm wondering if this will be a wireless. Try turning it on and off.
I would risk that. Okay. I don't know what's.
So cancel and try again.
Cancel.
So you can do anything else.
Alright, just reconnect into it. Sorry about this.
Yeah, I'm getting a response from again. I server. I'm telling you it's too wireless.
Is it? Okay. Might have lost presenter. Vadim's not here, so I think I lost my presenter status in there. Hey guys, can you guys hear me on WebEx? If I lost the team's host, I can't represent.
We'll post the video later. We can continue on.
Yeah.
If he can't make you presenter.
Yeah. Yeah. Okay. So yeah. Okay. Nothing I can do here.
You're only sending that those.
Chris, you gotta send that out to
Gotta send
everyone.
it
It's
out to
only being
everyone.
sent to host.
Oh, is it? My bad.
Chris, try to see if you can drag the balls here.
Yeah.
Okay.
Okay, I can just drag this.
Yeah. Oh, the ball.
The ball.
Try to.
Where's the ball at?
But blue and green.
Drag it to me. Sorry, guys. I wish Vadim was here, but nothing to do. Okay. I think I just got disconnected from the whole thing. Okay, so All right, I'm just gonna have to continue. Yeah, nothing I can do here. All right, so let me get back to where I was. All right, so all right, the dispatcher is responsible for sending actions to the stores. Okay, the stores are where we're going to store our state. So it's kind of a pub sub model if you think about it. The dispatcher is just providing the publishing in the pub sub. So it's just sending that to the stores that the stores are subscribing to. Okay, so the stores store application state, and they also describe how to react to actions. So based off of these actions, the stores are read-only. You cannot mutate the state from outside of the store. Only the store can mutate its state based off the action that it's listening for. So if that's create message, it may add a create message. It may add a message to the messages array. Okay. So what's the benefits of this type of model? If anyone's familiar with event sourcing, that's the concept of it's more of a database concept, but it's kind of produces this event log that describes how your state mutated to the current state. So it creates a record of all the mutations by logging these actions. This enables you to do cool things like time travel debugging. Makes it easier to reason about your code because it produces like better logging, better debugging. You can get your application back to a state that was currently in. If one of your customers, for example, is having an issue, and you have a log of what actions they did, you can reapply that in your own developer environment to get back to that state. And to figure out what caused the bug in the first place. You can also do things like hot module reloading, and I'll show that live in just a minute, but hot module reloading is the ability to change the logic of your application and have it hold the state while you're developing. So you can say you're doing a form wizard and you're on page 3 of a form, then you can change the style and look of your code. You can change the logic of your code. And when you save that file, it will refresh the browser and take you back to that step 3 with all the state that you had at that point. So that enables you to develop quicker. It's more of an iterative, it's better for iteration and doing software in an iterative process.
Can you join the WebEx account?
Yeah.
I apologize because
Yeah, my Wi-Fi disconnected.
and then I ended the session. So
Yeah. Okay, so just go back to this. Did everyone get kicked off?
yeah.
Okay.
Okay, and I'm gonna make a pause and then again. Sorry about that.
Okay.
Chris, I think there's more options to send to. So actually, it's like if you scroll down more, is there anything else? I guess
All attendees?
it doesn't let you pick all participants. Right now it's
Oh, okay.
It has you under panelists now, so.
Okay. Hey guys, sorry about that. Lost connection, and then the session got canceled. So we should be back. And can anybody hear me out there? Okay. Well, I'm just gonna press on because we've only got 30 minutes left. So I hope everyone joins when they can. Okay, awesome. Thanks. Okay. All right. So I'm gonna just quickly backtrack, and then I'll get back on the road. So Okay, so what for those of you guys that I lost on the WebEx disconnection, I'm just explaining what actions, stores, and the dispatcher do in the Flux architecture. And essentially, the dispatcher just sends actions to the stores. The stores they contain state and they listen for actions and mutate their own state based off of actions that they care about. Okay, you can have one or many stores inside your application. It's an architectural decision. You can use one giant JavaScript object and contain all the state for your object of your application, or you can break those up into just stores that represent each component. It's up to you. And there's pluses and minuses for each one. These are some of the benefits that you get by architecting your application in this way. You get event sourcing, you get a logged record of all the actions that occur to get you to the state that you're currently in, which enables you to do time travel debugging, makes your code easier to reason about. It gives you the ability to do hot module reloading, which I'll demo later. It also allows you to save the application state either to local store, or you could save it in an AJAX call to get the client back in the state they were in if they close the application and come back. You also get undo and redo for free if you simply log or save the record of the actions that got you into that state. You can just pop those actions off to get your application back into a prior state, and you can fast forward. Okay. So there's, like I said, there's many Flux implementations out in the wild. If you look up Flux, you're going to find a lot of them out there. There's Fluxor, there's Alt, a lot of them tend to name themselves after Back to the Future things because of the Flux capacitor, I guess. So you'll see a lot of them out there. The one that I'm going to use for this example is one called Redux. That's a Flux architecture implementation, and I'll explain how it's slightly different than Flux in just a second. But the tools that I'm going to be using for this example are React, Redux, Webpack, and Redux DevTools. Redux DevTools are what's going to enable me to replay my actions and time travel to show you how the application state has changed over time. I'm also using ES6, ES 2015, and you can check that out when you get a chance. So the key components about Redux is that we have one giant state object at the root level that controls the entire state of our application. So your entire application is in a single object tree that could be serialized or deserialized as needed. The state is read-only. That's a Flux imperative. Yes. There's no audio. Hello, testing. Yeah, testing. Hello. Seems to be working. It's showing volume. Hello.
It's working now.
Okay, awesome. Okay. So, all right, so let me get into the demo code, and I'll just jump into the code to show Redux in practice, okay? So I'm going to open up WebStorm. Go to counter example. Okay. All right. Let me start with the root component of this application. So we've got our app.js right here. Okay. With Redux includes some functions that it's a little bit of boilerplate. So what you're going to see here is some boilerplate. I'm not going to really go into that much detail about it, but the key thing about Redux is that you have things called reducers, which are simply functions that mutate your state, but they're pure functions, and that's the key part of it. Given a set of a state. Given a state and some action, it explains how the state should mutate, but it doesn't mutate the state directly, it just returns a new state. Okay, so let me show how that is. So we've got our counter app component, and we're passing in some props from at the higher level. We're passing in some action, some counter actions. Okay, so let's look at some of these actions. Okay, for example. All right, so we've got increment counter and decrement counter. So this is just going to be a simple page that's going to have like a plus and a minus. And if we click that plus and minus, it's going to tell us how many times we've clicked. And we can either decrement or increment the counter. All right, so we're importing these action types from a file, but what are they? They're not that complicated. They're just strings. So that's all we're doing here. We're just defining a couple string constants, and then we're listening. We're creating these action creators. So whenever we want to increment or decrement, we'll return these action objects, and you'll notice these are just types. There's no payload, so there's just simply objects with just an increment counter string attached and a decrement counter string attached. We've got an additional function that it will increment if it's odd. If you click a button on the UI, it will increment the counter only if we're in an odd state at that time. Okay, so that's where that logic is going. All right. What else do we have here? We have action. We have our counter component, which we're including incrementify, decrement, and counter as props in that component, and then we're using those props to describe the UI. So we've got our p tag. We're showing how many times the counter's been clicked. On click, on this button's click, the plus. When we click the plus button, we call increment. When we click the minus button, we call it decrement. We're getting those dependencies from the props, so that's getting passed down in from the counter op. So we're including counter, and we're passing it down in. So okay, let me show you how this works in practice. All right, so let me switch over to the application. Run the code. npm start. Okay. Okay. So again, all I'm doing is listening for events and decrementing here. But what's cool about what Redux and Flux enable us to do is that we can change the logic of our application and remember where we're at in our code. So this is simple enough logic to understand. But say I want the counter to increment by 5 each time I click that plus button. Well, I can change this to a 5 right here, this state plus 5. I can change that right here, and it's going to refresh, and it's going to remember. It's going to multiply by 5 the number of changes that I've done here. So each time I click plus 5, it's going to, what it's done is it's replayed the actions, all the pluses and minuses that I've hit, and it's enabled me to like maintain the state even though I've changed the application's code. So it's gone ahead and swapped out the components, and it's enabled me to just change things on the fly. So I think that's really powerful. We can simply save the changes and edit in real time in our code, and we can get real time feedback in our browsers about what we're changing. I think that's a powerful tool from a developer standpoint. It's easier to build things in an iterative fashion when you have this kind of behavior. So let me go into a little more complex example, and I won't go too much into the code. I'll share these examples, but I want to show you what you can build when you have. All right, let me pull this out of this one. Control C. Okay. Let's go back here. Let's start this one. So now I've got the classic to-do MVC application. Okay, so here's the classic to-do MVC example. All right, what we have here is we've got the to-do app. We can type in learn React, type in learn beard maintenance. We can type in these things, and what you see on the side here is a live record of the actions that are occurring in the background as I'm doing this interaction with UI. Here is the name of the action, which is add to do in this case. The text, which I typed, was learn React, and then the state after the fact is here's my list of to-dos. You've got learn React, and you've got use Redux. So that was the first action that I did. If I click this, I can undo that action. If I click this, I can undo that. I can reapply it, and I can delete, and it'll show a delete right here. I can I can mutate the state of my application. So I could go back here, and I could let's say I change the to-do text to say task list. And I save that. When I go back, it's going to say task list, but everything I typed is still there. It's kept that in memory. This is only something you would do in developer mode. To have this tool that records and shows that they can undo, and you can get back to the state that it was in. You would only do this in developer mode because from a performance standpoint, you wouldn't have this running all the time. But you can achieve things similar for clients to give them the ability to undo and redo their actions in a complex form application. I think that's useful for our programs because our programs are very complex. All the input forms that we have customers do are very complex, and they certainly, our users make mistakes. So giving them the ability to undo and redo actions is a powerful one. Yeah, so the point I wanted to get is that it makes the development process more fun, more iterative, it just enables you to build applications in a much faster way. And I just think that's really, really cool that you can see this. You could also wrap this up into a Chrome dev tool. There are some Flex implementations out there that have already implemented a Chrome dev tool. So instead of this showing up as these are just HTML overlaid inside your application, so these are just HTML elements. But you could embed this kind of behavior inside the Chrome dev tools, and there are some Flex implementations that have done that. There is one dev tool that I do have, which is the React dev tool, and that enables me to look at my my component, my application by looking at the React components, by mapping the HTML to the React components. Because if I just look at the element, it's just going to be a bunch of divs, and it's not going to be that easy to follow where in my React code was that particular piece of HTML defined. So with this React dev tools, I can look at the to-do app. I can see that it has these state variables attached to it. I can see the array of to-dos. There's 2 in there. I can see all the properties of those to-dos, and it makes it really neat for exploring your application. All right, so that's pretty much it. I'm going to wrap it up, but I just want to end by saying, by just summarizing. So we've got the idea that functional patterns can reduce your application complexity because state management is the source of most of our complexity in application development. When you eliminate side effects, you create functions that are easily testable. They're only concerned with what's passed into them, and then they produce an output given those inputs. It's easier from a developer standpoint to reason about them. It's easier with one-way data flow, to manage the interactions between components, and it improves your productivity overall. The virtual DOM on React gives you platform independence, server-side rendering for faster page load, which gives us fast performance overall whenever you're re-rendering many DOM elements. Okay, so I think I missed one last point, but the Flux pattern gives you hot module reloading, time travel, debugging, easy undo. Are there any questions that I can answer for you guys, or any comments, anything like that?
I got 2 questions.
Mm-hmm.
So, suppose you're migrating from Knockout to React. Or
Yes.
somehow you got yourself into having more and more library of framework
Right.
in the same page.
Right.
So one binds the real DOM elements, and the other is obviously virtual. Can they conflict? Can there be some kind of synchronization problem between those?
So there are examples of people migrating to React from other libraries. Now, with Knockout in particular, Knockout is an easier case, I think, than not migrating from like Angular, because Knockout is also a much smaller as far as what it's concerned with doing. You can include, so you could either do it page by page. You could include React into your core bundle for all your library code, and you could page by page. You could change all the source code for that particular page, but then the rest of your application still runs on Knockout. There are examples of people using Knockout and React components on the same page. Now you lose some of the performance benefits. You don't get server-side rendering and all that because you haven't gone full React. But it's a way to migrate it slowly an application. You can create and define React components, include them where needed, and then slowly migrate all your other application code over. That way you don't have to go all in, you know. Yes.
To add to that point, I think it depends where you might be applying the bindings with Knockout. Like if you're applying the bindings to the whole body, or they're just applying it to just a section, then perhaps another section of the page is, you know, controlled by not by React components or React architecture. But so yeah, it really depends on how you want to go about it. But
Yeah.
Okay. My second question is functional programming style as well as virtual DOM.
Yes.
Both memory intensive. Are there
So
any known issues from that?
no, React is if you look at benchmarks between React and Knockout and Angular, React consistently performs better. Now Angular 2, they claim to have better performance than React on Angular 2, but it's not like an order of magnitude better. It's just it's a linear, like linearly better, but it's and usually the performance differences only start to show when you've got a couple thousand elements on the page, which are, you know, probably not the typical use case for most applications. No, the virtual DOM is very, very performant because it's very easy. Changing out objects in JavaScript is a lot easier than changing out DOM elements. The re-rendering process and the applying of all the CSS rules is one of the most expensive processes in client-side code. So virtual DOM is definitely a performance gain, net performance gain. Any other questions I can answer? Any other comments? Okay, well, I guess we'll just wrap it up. Thank you guys very much. Appreciate you listening, and hope you guys experiment with it and try it out in your applications and I think you'll learn a lot, and I think you'll grow as a developer by learning these kind of patterns. I think it's just one more thing to add to your tool belt, and might teach you like a slightly different way of thinking about how to structure applications than the imperative style that like Angular and tends to lean towards. So, anyways, thank you guys very much, and we'll call it a day. Thank you.